Flaring tubing is a fundamental operation, regardless of which tools you use. From these basic hand tools to the most sophisticated flaring tools, all steps lead to the same end. We'll begin this series with the basic hand tools, the time-honored arbor press and bar. Flaring requires a quality tubing cutter and a square end on the tube. This is a rigid 15 SI with rollers. Cut tubing should be deburred inside and outside. This popular tool from Inline Tube is a 45-degree inside and outside cutting tool. Deburring the inside restores the diameter, as well as creating a smooth surface that is free of burrs. The 45-degree chamfer on the outside edge enables the tube to collapse more readily during the adapter or flare punch operation. A square tubing end and deburring is essential for getting a uniform and quality flare. Always remove debris to prevent damage to seals within the braking system. The goal is smooth, concentric surfaces. This split bar flaring tool uses wing nuts and ridged jaws to secure the tube. The tube must be secured tightly in order for the dies to be able to push the tubing into shape. This die set is for inverted flare, and the first step is to choose the 3/16 inch die and set the depth of the tube to the shoulder height of the die. At this point, the clamp is secured tightly, often requiring a wrench or channel lock pliers. This is the arbor with a 45-degree cone, the same shape as the seat for the flare. This die or adapter will form a convex flare. The bottom half is the 45-degree flute for the bottom half of the flare. The top half is a bubble at this point. The die must compress the tube squarely and seat completely before this step is done. The deburring of the outside edge makes it easier for the tube to funnel into the die. Marking the tube with a fine felt tip pin will help determine whether the tube stayed stationary during this process. Apply force evenly until firm resistance is met. Here, a problem is apparent. The tube has pushed through the bars. When the tube slides like this, nothing gets formed, and the tube itself becomes marred by the teeth on the split rail bar. Sometimes tightening the wing nuts further will secure the rails. Other times it's practical to use the bench vise to squeeze the two split rails together. Leave enough room for the yoke to fit over the top of the split rail bars. Notice that you rotate the yoke in the direction that the stem turns. This will keep it from shifting or cocking out of position. Turn the handle with even force and make sure that the adapter is pressing squarely against the tube. Once the adapter die has seated firmly against the rails, back off the stem and remove the yoke and the adapter die. At this point, the bottom half of the inverted 45-degree flare is formed. The pressure of the bench vise kept the tube from sliding through the bar. Once again, the bar is secured in the bench vise, and the cone and arbor will now create the top half of the double inverted flare. Turn the stem handle evenly with uniform force to compress the upper seat. This will be a double inverted flare of 45 degrees on the bottom and the top. Despite the time involved and use of a vise to complete the job properly, the end result is a 45-degree inverted flare that looks quite good. Note that the inside diameter of the seat is uniform with the inside diameter of the tube. This will not restrict brake fluid volume. Above the flare on the tube, you can see marks from the side rails of the bar, one of the pitfalls of this type of flaring tool. If cosmetics are important, this is a problem. However, from a utility standpoint, this is a nicely formed flare. A sensible alternative is the use of a single flaring tool from Rigid, the number 345 commonly used for plumbing jobs. This has a split bar and the use of a side handle that compresses the bar right at the location of the tube. If we were just cutting off the flare, we would use the mini tubing cutter, but in this case we'll use the roller cutter and cut back further to a clean section of tubing. This time let's make this a technically accurate seat that also looks good and has the proper amount of zinc coating to protect from corrosion and rust. Again, flaring always begins with deburring the inside and outside diameters of the tube. The inside diameter needs to be true and the outside needs a chamfer of approximately 45 degrees, which enables the tube to collapse better during the flaring process. Some use a file for squaring or deburring. I prefer this deburring tool for its accuracy and 45-degree angles. Remove any debris or metal particles from the tubing end. Clean the tubing out thoroughly before installing it. Adapters are available for double lap flaring with this Rigid 345 tool. Rigid also has this tool with the adapters and a tubing cutter in a kit form. Here I'm using adapters from the old Forge tool set. The stick-out length for this 3/16" tubing is the first step on the shoulder of the adapter. This must be level and even for each flaring job. The significant difference with this arbor is the side handle adjuster and tensioner. This assures that the tube is squeezed tightly enough to prevent it from slipping through the bar. A successful flare requires that the adapter be square with the tubing. The substantial arbor and side clamp force right at the tube area makes this tool versatile. It works very well with single and double flare if you have the adapters. The 45-degree adapter for a double flare creates the bottom side flare and bubble or convex flare in the first step. Tighten just enough for the adapter to rest squarely on the bar. For occasional or trail usage, this would be the ideal tool. For a basic level flaring tool, the Rigid 345 bar and arbor with adapters is the best I've found. Some call this a bubble flare. This is actually a 45-degree convex flare, or the first flaring step in a double inverted 45-degree flare. Either type is considered SAE and not DIN, or European metric bubble. This first step convex flare is similar to the old Girling style flares. The second step shown here is the cone going into the convex dome or SAE bubble, and folding the dome inward produces a 45-degree double inverted SAE flare. Snug is tight enough. Over-tightening will damage tubing and tooling. It is always practical to practice flares and flare seat forming before performing this task on an important job. If done smoothly and properly, this is the kind of quality 45-degree inverted flare seat you can produce. The double lap is formed nicely and the bore is uniform without any restriction of brake fluid flow. The tubing did not slide at all, and the result is a backside that looks much better with this bar than with the less expensive types of flaring tools. This flare and flare seat have a professional look similar to machine manufactured tubing. The rigid arbor and thick quality bar with a side clamping force accounts for the quality of this flare. Let's repeat this procedure and produce another flare. We'll begin by marking the tube to see if it moves at all during the flaring process. The tube extends through the bar the thickness of the shoulder on the adapter. Again, this is the adapter from the old Forge set. Rigid also offers adapters that can be used with the 345 flaring bar and arbor. The 345 arbor and bar are commonly sold for single flaring, but this tool is designed to do inverted double flare 45-degree seats. The bar is very stable in the vise, and the handle can be turned smoothly until resistance is felt. This first step brings the adapter flush with the bar. Again, we have formed the convex of an SAE double flare. The 45-degree cone in the arbor will now create the double side of the flare. The end result will be a 45-degree inverted flare seat. The arbor side clamp holds the two sides of the bar tightly together and also aligns the cone with the tube. Here the cone collapses the convex section of the flare and firmly presses it to form a double lap seat. Note the force applied to the handle to assure a compressed seat. Removing the arbor reveals a double flare 45-degree inverted flare. Note that the tube did not move through the bar when force was applied. This is ideal and minimizes any risk of damage to the tube behind the flare. The double flare inverted 45-degree seat is well formed. There is minimal marking on the back side of the flare. The squeezed area behind the flare end of the tube has been minimally impacted. The zinc coating is in place and will prevent rust and corrosion from forming. Debris can be readily cleaned away with Scotch-Brite. This will polish the surface and make a good contact between the tapered tube seat and the fitting or flare seat. Scotch-Brite polishes the metal and provides a smooth mating surface. Always clean or flush away debris with compressed air or a solvent such as denatured alcohol that will not damage rubber. Always avoid the use of mineral spirits or any product containing petroleum distillates, as this will cause swelling of brake seals and cups. The traditional cleaning substance for brake systems is denatured alcohol for cleaning up parts. I use denatured alcohol for cleaning and flushing any parts related to a braking system. Then allow the parts to dry completely or use compressed air to speed up the drying process. Beware that many products represented as brake cleaner actually contain petroleum distillates and harsh chemicals which can be used on brake backing plates and other metal, but should not be used near rubber parts, seals, or rubber cups and dust boots. Always remember to put the flare nut in place before forming the flare end. This is an example of a flared end ready for service.